far, we've talked about a refresher of graphing quadratics. We did a refresher of standard form and vertex form, what they tell us, how I swap between those two formats. So today we're going to talk about our last function form for quadratic equations, and that's factored form. Okay. So factored form for a quadratic function. Does anybody remember what that tells us? The x-intercepts. Yep, the x-intercepts. So the generic version of factored form looks like this. We've got that lead coefficient in here again. Remember, this a value tells me the same stuff as our a values from standard form and factored form. So it tells me about the shape of my graph. Am I opening up or down? Are we stretched or compressed at all? So that a value is the same as it was for our other function formats. But this time we get x-intercepts, and they come from here and here. So our x-intercepts would be m and n. Those are our x-intercepts. Just like with vertex form, when I pulled that x coordinate out and I had to swap that sign, the same is true here when I pull out my x-intercepts. So if this were x minus 2, my x-intercept would be positive 2. If this were x plus 5, my x-intercept would be negative 5. So we have to be careful with those signs. Now, the first thing I want to do today is the same thing we started with yesterday. So yesterday we started with some examples where I asked you what form is this in and what do I know about the graph. So we're going to do the same thing here, but this time all three forms are fair game. So remember last time we had standard and vertex form. Now we're adding in factored form. So we've got three options here. So you're going to identify that function form for me and then tell me what we know about the graph. So for our first example, what form is this in? Yep, this is in standard form. And what does standard form tell me about the graph? Good, the y-intercept. And what is the y-intercept for this function? Yeah, remember we look at that constant term at the end, the thing that doesn't have an x. I don't see anything here, so that means that it's 0. How about example 2? What form is that in? Factored. What does factored form tell us? The x-intercepts, good. And what are the x-intercepts for this function? Very good, -1 and +3. Now, I've listed my x-intercepts as sort of a list here separated by a comma. That is absolutely okay. If you would rather write out -1, a and b, 3, that's also fine. Or little and shorthand, that's all good. The only thing that's not okay, and we saw this a few times and we talked about it back in Unit 8, is if you were to write -1, comma, -3, and then slap parentheses around that. I had a few people doing that back in Unit 8. This is not okay. This, as soon as I put parentheses around it, is now the point -1, comma, 3. That's not an x-intercept, right? It's not on the x-axis. It is not an x-intercept, and that is not what you were trying to tell me when you list off x-intercepts. So make sure we do not have parentheses around our list of x-intercepts, okay? Be careful about that. Example 3, what format is that function in? That's vertex form. What does vertex form tell me? Yeah, that one's really tricky, right? Vertex form tells me the vertex. What is our vertex here? 1, comma 4. Now here, I am naming a point on the graph. I'm creating an ordered pair, so I do want parentheses around the vertex. And then finally, example 4. Why is this one tricky? Yeah. For factored form, we like to have 2 sets of parentheses, right? Do you remember for some of our vertex form problems last time we had something like x² + 3, and we said, hey, that's actually vertex form. What's happened is I have x minus 0 squared, and so we just simplified it. Remember that from last time? Okay. What we're actually doing is the same thing here. okay? What I had here was x minus 0, but when I subtract 0, or if I were to add 0, that doesn't actually change my x at all. So instead of having to write out the x minus 0 in parentheses, we simplified it to just x. So this actually is factored form. What are our x-intercepts? Yeah, 0 from the x and -5. Good. Questions for me so far? Okay. So what we're going to look at for our next several examples is how to change a function from standard form into factored form. So we're going to start in standard form. We want to get factored form. So to do this, we have to do something called factoring. Okay, we spent a lot of time in Unit 8 and then again in Unit 9 working on factoring. We're going to review it again today. Just some reminders for you guys as we're looking at factoring. Excuse me. The first thing I want to do when I'm factoring for any problem is start by looking for a GCF. Remember, GCF stands for greatest common factor. A greatest common factor would be something that I could divide out of every term in my quadratic equation. So maybe every number in there is even and I could divide them all by 2. Or maybe every term has an x. So my GCF would be x and I could pull it out and not have any remainders. Maybe every term is a multiple of 7. And so I could divide everything by 7. That's the idea of a GCF. I want to start by pulling out any GCFs that I have in my problem. If my lead coefficient is not 1, that A value, if it's not 1, remember that we need to use AC method, and we'll see some examples like that today. And then the last thing to be on the lookout for are those difference of squares problems. If I pulled out my GCF and I have something that's an x squared guy minus a number, I want to think difference of squares. So let's go ahead and start with example 5 here. Do I have a GCF to pull out? No greatest common factor here. Nope. And my lead coefficient, my A value is just 1. So to factor this, I'm going to look for factors of C that add to B, that add to -3. So I want two numbers that would multiply to give me -4, but add to give me -3. What numbers do I want there? -4 times 1. Good. Remember when we talked about this the first time around, I said if you need to, make a list. 1 times what, 2 times what, 3 times what, so on and so on. Be careful with your signs. So then my factored form here would be x minus 4 times x plus 1. These numbers right here, I plop right into my factored form. How about example 6? Do I have a GCF there? No, I do not. So I'm going to look for factors of C, which is 12, that add to B, which is 7. 4 and 3 will work. So my factored form then would be y equals x plus 4 times x plus 3. Now, on your paper, if you thought of this as 3 times 4, and you said my factored form is x plus 3 times x plus 4, you are absolutely correct. That's the same thing. Remember, the order of the factors is not important. As long as you've got x plus 3 and x plus 4, you're good. Let's take a look at example 7. Do I have a GCF there? Yes, I do this time. I can divide all of these terms by 2, so that's what I'm going to do. Most common error I saw when we had these GCF problems where we took it out of the first term, but then we didn't divide the GCF out of anything else. Remember, I have to divide it out of every single term in my problem. So that would leave me with x squared plus 6x plus 8. Okay, I have to divide 2 out of all of those pieces. Now, what I have in parentheses has a lead coefficient of 1, so I could treat it just like we did 5 and 6. So I want factors of 8 that add to 6. Factors of 8 that add to 6. 4 times 2. So my factored form would be y equals 2 times x plus 4 times x plus 2. Don't forget your GCF when we're writing factored form. I know that's a mistake I make all the time. You just are knocking through your factoring problem and you get your values that you need here, you jot them down, and you completely forget about that GCF. So just be on the lookout for that. Example 8, do we have a GCF there? Yes, we do. What is it? -3. Yeah, anytime your least coefficient is negative, even if that A value is just -1, I would pull out -1 as your GCF. Your work later on is going to be a little bit easier if your A value is positive. Okay, so we're going to pull out -3 here. I can divide all of these terms by -3, so that makes it a GCF. So that gives me x squared minus 6x plus 5. Now what I have left in parentheses has an A value of 1, so I'm going to treat it just like I did 5 and 6. So factors of 5 that add to -6. Factors of 5 that add to -6. -5 times -1, that'll do it. So this would be, for my factored form, y equals -3, don't forget that GCF, times x minus 5, times x minus 1. Questions for me so far? Okay. On the next page, we're going to look at some more factoring examples. So for example 9 on the next page, do I have a GCF here? No, my smallest value is a 2, but 5 and 3, or more -5 and -3, they're not even, so I cannot evenly divide them by 2. I don't have a GCF. I can't divide. There's nothing I can divide all of these by. Now, since my A value is not 1, that means I'm going to have to use AC method here. Remember, for AC method, I start by multiplying my A value and my C value. So 2 times -3, that gives me -6. And now I want factors of -6 that add to -5. 1 times -6, that works. Now at this point, I cannot jump straight to my factored form, okay? Factored form for this is not x plus 1 times x minus 6. If I were to multiply that back together, I would not get 2x squared minus 5x minus 3, okay? So for AC method, remember we've got those extra couple of steps. I'm going to use these numbers instead to replace that middle term, to rewrite that middle term. So I keep the 2x squared, I keep that first part exactly the same. I rewrite the middle as plus 1x minus 6x, and then I keep the ends the same. So the ends are the same, the middle is what I rewrite using those factors that I've selected here. And now that I've got 4 terms, we're going to split this up into 2 groups. From here, I'm going to look for the GCF for each group, that common factor for each group. What do I have for my first group here? My GCF, x, right? These both have an x, so we can pull out an x. That leaves me with 2x plus 1. What's the GCF for my second group? I'm sorry, what was that? 3. And since the group starts with a negative, I'm going to go ahead and take out a -3. So when I divide -3 out of here, I'm left with 2x plus 1. Remember, when we're using AC method, my stuff in parentheses should always be the same. If it's not, you need to go back and double check your work because something's wrong. So make sure that you pulled out your whole GCF, make sure you divided it out of each term, and then make sure you pick the correct factors here, okay? Those are most common errors that I see if we get something funky. Since my stuff in parentheses is the same, that acts like a new GCF that I pull out. So 2x plus 1 comes out, and then my other factor is what's left over. So that would be x minus 3. Here's my factored form. Now, let's say that you had written down -6 times 1. And so in your format here, you had 2x squared minus 6x plus 1x minus 3. Okay. When you split this into groups and look for your GCF, you're going to get something different for this next plot. So if I have these swapped, my GCF for the first group would be 2x, and I'd be left with x minus 3. My GCF for the second group, I don't have anything interesting there, but I have to pull something out. So my GCF would just be 1. That would leave me with x minus 3. So this and this are not the same. That middle line is different. However, x minus 3 is the same. I pull that out. And my other factor would be 2x plus 1. So I still get the same factored form. I just get it a little bit in a little bit different way. Does that make sense? Okay, so if you've swapped those middle numbers, that's okay. You're going to get the same factored form. Question? I am going to stop at 2x plus 1 because the x doesn't have a power on it anymore. Does that make sense? Okay. Questions for me on 9? Okay, let's take a look at 10. Okay. Do I have a GCF here? Nope. Since my a value, my least coefficient is not 1, we have to use AC method again. So 3 times negative 8, that gives me negative 24. I need factors of negative 24 that add to 10. 12 times negative 2, that will do it. So 3x squared plus 12x minus 2x minus 8. And then split this up into groups. What's the GCF for our first group? 3x. So when I factor out 3x, I'm left with x plus 4. How about my second group? Negative 2. When I divide negative 2 out of here, I get x plus 4. Again, stuff in parentheses should always be the same. Since it is, I get to pull that out. And then my other factor would be 3x minus 2. There's my factored form. For example, 11, do I have a GCF there? Nope. And then I want you to notice x squared thing minus a number. When I only have 2 terms and it's something with x squared minus a number, this is where we think difference of squares, okay? So this is where we said, hey, figure out what we square to get each of these. So what do I square to get x squared? X, right? This is the thing that sounds like a trick question, but it's not. And then what would I square to get 9? 3, there we go. So then my difference of squares pattern says my factored form would be x plus 3 times x minus 3. Notice that that first thing goes at the front of each factor, the second thing goes at the back of each factor, and they have opposite signs between. That's our difference of squares pattern. Number 12, do I have a GCF there? No, we don't. And again, it's x squared thing minus number. So I should think difference of squares. Now, in this case, it's not just x squared, it's 4x squared. So if it helps you, you can break this down into the number and then the x. So what would I square to get 4? 2. And then what do we square to get x squared? X. What do I square to get 25? 5. Okay. If you want to tackle this as 4x squared, that's fine too. I know for a lot of us, it's helpful to do the number and then the x. So then my factored form here using our difference of squares pattern would be 2x plus 5 times 2x minus 5. Questions for me so far? Okay, so I want you guys to take the next couple of minutes and work on the last 4 problems, okay? This is just like how we ended yesterday. So I'm giving you a function in one of the 2 forms that we've just been working with, standard or factored. I want you to identify the key features that you can from the function as it's written right now, and then change it to that other form to get the rest of the key features I'm asking for, okay? So try these last 4 problems on page 7. I know you may not be quite finished yet, but I do want to take a look at these together before the end of the period. So let's go ahead and look at number 13. What form is this in right now? Standard. What do I know from standard form? The y-intercept. What is our y-intercept for this function? -7. I want to know the x-intercepts as well, so that means I need to factor this. Do I have a GCF here? Nope. So we have to use AC method. So 5 times -7, that gives me -35. I want factors of -35 that add to +2. What factors will I use here? Yeah, +7 and -5. It's always kind of nice when it's the numbers you multiply together or something really close. So this would be 5x squared plus 7x minus 5x minus 7. And then we group. GCF for my first group, just x here. That leaves me with 5x plus 7. The GCF for my second group, nothing like terribly exciting, but my group does start with a negative, so I'm going to pull out a -1, which would leave me with positive 5x plus 7. My stuff in parentheses is the same, so my factored form would be 5x plus 7 times x minus 1. Now for my x-intercepts, let's get the x-intercept from here first. What's the x-intercept from my x minus 1 factor? +1. And then this guy's a little trickier. My x-intercept from here is not -7. Remember, I've got that 5 in front, and that's going to play a part in my x-intercept. So what we would do for something like that would be to take our factor, our 5x plus 7, and set it equal to 0 and solve for x. That will help us make sure we identify our x-intercept correctly. So I'm going to move that 7 to the other side, and we do get a -7, but then we need to divide by 5. So our x-intercept from here would be -7 over 5. For 14, what form are we in right now? factored, so we know the x-intercepts, and what are they? -2 and +7. Very good. Now to get the y-intercept, I want to change this to standard form. We do this the same way we changed our vertex form to standard form. So I'm going to distribute. X times x is x squared minus 7x plus 2x minus 14. And I'm just going to tidy this up by combining my like terms. So I get x squared minus 5x minus 14. So my y-intercept is -14. Down at the bottom here, this should be 15 and 16, but number 13, part 2. This is in standard form, so our y-intercept is 16. To find the x-intercept, we're going to factor. We do have a GCF of 4 here, so I can pull that out. That would leave me with x squared plus 4x plus 4. Some confusion I've seen before. So do I pull the GCF out? GCF out, and then my y-intercept is that number? No. The point of standard form is that I can see the y-intercept without having to make any changes to the function. So remember, I'm looking at the original standard form for that y-intercept. And then from here, factors of 4 that add to 4 would be 2 and 2. So my factored form would be 4 times x plus 2 times x plus 2. So my x-intercept would be -2. And then I would get the same x-intercept for my other factor. When you have the same x-intercept multiple times, you could write it multiple times if you'd like, or just write it once. Either is fine with me. And then finally, for 14 part 2, we're starting in factored form. So I know my x-intercepts would be -8 and +8. To find our y-intercepts, we're going to distribute to get standard form. So this would be x squared minus 8x plus 8x minus 64. When I combine like terms, I have x squared minus 8x plus 8x, means I've got no more x's, minus 64. So my y-intercept is -64. Questions for me? Okay, so factored form. Remember, always start by looking for a GCF. Use AC method completely. If your A value is not 1, look for those difference of squares.